So we start geometry with a review of Algebra 1 stuff. So this is a first semester Algebra 1 solving using properties from algebra. We have some properties we got to go over. Addition property of equality. If you have two numbers that are equal to each other, or two expressions that are equal to each other, then you can add the same thing to both sides of the equal sign. Whoa, crazy, right? Same thing for subtraction. If you have two expressions that are equal to each other, then you can subtract the same thing from both sides of the equal sign. Same thing for multiplication. And same thing for division. You can add, subtract, multiply, or divide both sides of an equal sign by the same thing. Substitute. We are allowed to substitute. If we know A equals B, then we can replace A with B in any other equality. And the distributive property. Very basics of algebra here. We've got to be able to add, subtract, multiply, and divide to both sides of the equation. You have to be able to substitute, and you have to be able to distribute. We need all of that to do our linear work. We're going to substitute all the time in this class. We do lots of substitution all year long. We use the properties of equality all year long. We distribute all year long. So these aren't things that go away. These are the basics. So how do we know which property to use? We use the inverse operation, the operation that undoes. So for adding, we subtract. For subtracting, we add. For multiplying, we divide. For dividing, we multiply. So when we have, like example 1, very basic one-step equations. If you have x plus 7 equals 15, you want to undo the adding of 7 to get the x by itself. That's what solving for one variable means. Get the variable by itself equals everything else. So we write minus 7 and minus 7, and we get x plus 8. That's using the subtraction property of equality. And then simplifying. Usually we're going to combine those two things to just write the subtraction property of equality, understanding that we're doing both the subtraction property and simplifying at the same time. If you want to go even more in depth there, you're really taking both sides of the equation and subtracting the 7 from it. So that positive 7 and negative 7 is 0. And anything plus 0 is itself. But generally, our notation is just going to look like subtracting 7 from both sides of the equal sign. Otherwise, you have to write a lot more. So in example 2, the opposite of subtracting 5 is adding 5. So we use our addition property of equality to add 5 to both sides of the equal sign. And we have solved for x using the addition property of equality. Here we have 2 multiplied by x equals 14. So we're going to divide both sides by 2. Simplifying, we get x equals 7. We're using single properties, division property of equality. We already have x divided by 4 equals 3, so we're going to multiply both sides by 4. So on the left, we get 4x over 4, which is 4 over 4 is 1x. That's why we did it. So we use the multiplication property of equality, and we simplified. On all of these, it's a good practice to check. 8 plus 7 equals 15. Yes, 15 does equal 15. 18 minus 5 should equal 13. Yes, 13 does equal 13. 2 times 7 equals 14. So 14 equals 14. And 12 divided by 4 should equal 3. Yes, 3 does equal 3. Notice how when you're checking, you're not just saying 8 plus 7 equals 15. You're actually showing that the left-hand side and the right-hand side simplified to the same thing. Those are your 4 one-step equations. Then you do 2-step equations, where you have to do 2 of those things at the same time. So we've got to subtract 3 and simplify, and then divide by 2 and simplify. As our equations get more complicated, the check step becomes more important. Being able to check and simplify one side and show that it equals the other, an important skill. We're going to add 5 to both sides. And we're going to multiply both sides. Multiply both sides by the denominator, the 2. So x over 2 times 2. And negative 2 times 2. We're going to check. Negative 4 divided by 2 minus 5. Better equal negative 7, or we really screwed up somewhere. Sure enough, negative 7 equals negative 7. Check. Those are our 2-step equations. Multi-step equations. There's lots of different multi-step equations. So we're just going to go over some of the common ones that we see all the time. Variables on the same side. If you have variables on the same side of the equal sign, you want to combine your like terms. There's 2r minus 4 plus 3r. So there's 2r and 3r on the same side of the equal sign. So there's really 5r on the same side of the equal sign. Whenever you're doing something on the same side of the equal sign, your reason is always simplify. Sometimes you have to simplify before you get to do anything else. There's lots of different types of simplifying. We'll see loads of different words that go along with simplify. The word here was combine like terms. That's a type of simplifying. Then we're into our 2-step equation. We add 4 to both sides and divide by 5. So r equals 1. We added and we divided. Our check step, 2 times 1 minus 4 plus 3 times 1 equals 1. 2 minus 4 plus 3 equals 1. So 1 equals 1. Check. Another very common type of multi-step equation is when variables are on opposite sides of the equal sign. So when they're on opposite sides of the equal sign, in general, you want to get them on the same side of the equal sign using a property of equality. And it doesn't matter which side you get them on, you're still trying to get the variable by itself. Lots of people like to put it on the left-hand side. Lots of people like to subtract whichever one is smaller. Doesn't really matter which one you do here. I'm going to subtract 6p from both sides, so that 6p minus 6p is 0, leaving just the negative 8 on the left-hand side. And all the p's are together on the right-hand side of the equal sign. Now we're in our 2-step equation. We subtract 6 from both sides. And we divide both sides by 5. You are definitely going to get loads of fractions in this class. Learning how to use fractions effectively is something that we need to work on mastering. So, how did our steps go there? We used the subtraction property of equality to get our p's on the same side of the equal sign. We used the subtraction property of equality again to get the constants on the same side of the equal sign. And then we use the division property of equality to get the variable by itself. Our check step, we're putting in the negative 14/5. And checking to make sure both sides are going to be equal. When you multiply a whole number by a fraction, you put it over 1, multiply the top times the tops, and the bottoms times the bottoms. So negative 72/5 minus 8 equals negative 154/5 plus 6. When adding fractions, you have to find common denominators. Our common denominators are 5. So we're going to multiply by 5 over 5 to make those denominators the same. So negative 72 minus 40 all over 5. And negative 154. Six times 4 is 24. Oh, I really multiplied wrong when I did 6 times 14. 6 times 14 is 84. Oof, duh. So I get negative 124/5 and negative 124/5. The left-hand side and the right-hand side are the same, and it checks. The distributive property would be the third type of thing that's going on here. So I'm going to show you two different things with the distributive property, both pretty easy problems. The first one is when the denominator, if you have a fraction out front, matches or is a factor of the terms inside the parentheses. So one of the things we can do is we can just distribute using this distributive property. 2/3 of 6 is 4. 2/3 of 9 is 6. Then you're in your two-step equations. You subtract 6 from both sides and divide by 4. So we distributed. We subtracted 6 from both sides using the subtraction property of equality and simplifying. And then we divided both sides of the equality by the same number and simplified. Our check step. So we have 2/3 of 6 times 3/2 plus 9 should equal 12. 2/3 inside the parentheses, 3/2 of 6 is 9. 9 plus 9 is 18. And 2/3 of 18 is 12. So things that we do as scratch work off the side, if you don't know the 2/3 times 6, you do 2/3 times 6 off the side. That's called scratch work. Multiplying the top times the top, you would get 12 over 3, which is the 4. Same thing with 9. If you don't know what 2/3 of 9 is, not a big deal. You just do your scratch work off the side. 2/3 of 9. 2/3 multiplied by 9 gets us 18 over 3, which is where the 6 came from. Fraction work is just fraction work. It's something to get used to. It's something you have to practice. We want to practice it with our nice, reasonable numbers before we get into having to work with fractions of square roots, of sines, cosines, and tangents later in the semester. We do a lot of fraction work with a lot of stuff. These are the easy fractions so that we can practice our fraction rules and be able to do them when we get to the harder stuff later on. If you choose not to practice your fractions now, you will have no chance later on. So please, please, please do what I'm asking you to do. Practice fractions with us. There's multiple ways to use fractions. Sometimes we're doing what we did in example 9. Sometimes in example 10, the denominator 2 does not go evenly into the 7. So one of the things we can do is multiply both sides by the denominator. So 2 multiplied by 1/2 and 2 multiplied by 32. 1/2 of 2, 2 times 1/2 is just 1. 1 times anything is itself. So we just have 4m plus 7 equals 32 times 2 is 64. Multiplication property of equality. And simplifying. Then we're in our two-step process. Subtract 7 from both sides. 4m equals 57. Yuck. Divide by 4, and m equals 57/4. We're going to check our answer. So we take 1/2 of 4 times 57/4 plus 7. And we should get 32. 1/2, 4 over 1 times 57 over 4. The 4's cancel out. So we have 57 plus 7, which is 64. And half of 64 is indeed 32. We're going to have to do word problems this year. We're going to have to figure stuff out this year. We're going to have to be very thoughtful this year. All of these things go hand in hand. The table shows the number of ripe raspberries on a plant for the first 4 harvest days. The remaining 10 days follow the same pattern. Find the number of ripe raspberries on the 10th day of the harvest. So there's a couple things going on here. The remaining 10 days follow the same pattern. Means 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That if we want to think about 10 more days of harvest, there's 10 more days of harvest. Luckily, it's asking for the number of ripe raspberries on the 10th day of the harvest. So day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we're looking for that day. If they just said, find the remaining, or find the number of ripe raspberries on a plant after 10 more days, 10 more days would be day 14. So you gotta read your problem, you gotta figure out what they're asking, all of that stuff that goes into analyzing and figuring out what the problem is actually talking about doesn't go away, it's still here. Since we have had algebra already, we're going to look at this pattern and not just go, okay, it's obviously adding 2 each time, so that's going to be 20, 22, and count all the way up to 10. Because what if they ask us for the 100th day of the harvest? I wouldn't want to count all the way up there. We have good algebra skills, so we can see that it's plus 2 each time. We don't need to keep counting like that. We can instead use our wonderful algebra to say, well, the days and the raspberries have an equation that goes into how we can find them. The number of ripe raspberries is given by 2 times the number of days plus 10. When you plug in 1, 2 times 1 plus 10 is 12. When you plug in 2, 2 times 2 plus 10 is 14. When you plug in 3, 2 times 3 plus 10 is 16. So this is the relationship for that table. So then they can ask us any day they want, and we just substitute in. So substituting, the 10th day is day 10. We have the number of ripe raspberries on our bush is 30. Number of ripe raspberries on the plant. They're raspberry plants, not raspberry bushes, apparently. And there's our answer. At the bottom of this, I gave you some math rules. Hopefully it's stuff that you already know, that you have easy access to. A positive plus a positive is a bigger positive. Any negative plus another negative is a bigger negative. If you have a big positive plus a small negative, you get a positive. If you have a small positive plus a big negative, you get a small negative. The basics. Negative fraction stuff. How to cancel correctly. Some special fraction stuff. I didn't have enough room to put in adding and subtracting fractions. All this stuff is stuff that we're going to see that's going to come up. So we'll get the other fraction rules as we go along, but they're the same fraction rules you've been working with since grade school. They haven't changed at all. I will try to unconfuse some of the fraction rules for you, but we'll see how it goes. Hope you had a good time, and I'll see you tomorrow.